सामने वीडियो
Assalamu alaikum to everybody. In the previous class, we were discussing about Z compressibility factor and van der Waals equation in different forms at moderate pressure, at high pressure, and in case of hydrogen and helium. Then we have taken the graphical representation of ideal and real gases. Today, we are trying to take up the last topic of gaseous state chapter. Right. When you are saying that if you want to talk about those students who are sincerely following the rhythm of the subject, sir, we discuss about compressibility, reality, then compressibility. Once you have compressibility, go one step ahead. What happens? If you are goes on compressing a gas, then there is a possibility of liquefaction. Yes, today we try to enjoy the concept of liquefaction, but the concept is liquefaction, but we are having some different type of heading available with us. For that, I'll take another slide. Suppose, for example, I want to study Boyle's law. I say I want to study Boyle's law. You say, sir, already we have done Boyle's law. Why again we are discussing Boyle's law? Remember that here there is a beautiful way of enjoying Boyle's law. One fellow by name Andrew, right? What people say in at higher level of understanding, and teachers and lecturers says that great people do not do great things. They do things in a different way. Great people do not do different things. They do same thing but in different way. How to enjoy this concept? We have done Boyle's law, and this fellow to whom we are discussing today, he also studied again Boyle's law. But see what is the way with he enjoyed the Boyle's law. That person is known as Andrew, right? He has studied isotherm. Boyle's law is discussed under the heading of isotherm, and he has taken one specific gas, carbon dioxide. So today we are trying to understand the concept of behavior of Boyle's law and how to talk about variation of pressure with volume. What is Boyle's law? Variation of pressure with respect to volume at constant temperature, right? Now, if we are discussing that, let us see what he has done. He has first selected the carbon dioxide, then he found a temperature at which we are having ideal behavior of carbon dioxide. Okay, sir, in the previous graph, when we are discussing all this, we have taken Z versus P and we have said this is non-ideal, this is non-ideal. But here we are saying that the line is crossing Z is equal to 1, right? If you want to understand this, there is one more 4 marks question possible. Let us add up that one also. Here, let us try to understand Z versus P of a gas. Let us take only one gas at different temperatures. I am taking different temperatures. When you are taking one temperature, it is called isotherm. Now I am taking isotherms. So many are there. Let us see how to proceed further. This is a beautiful 4 marks question for both of you, for doctors and scientists. Suppose if I have taken Z here, and here I have taken pressure, same graph, but in the previous class we have taken for different gases. Now I am taking for only one gas, any gas. I'm not taking the name of the gas, any one gas, and I want to study at different temperatures, So what is that normal behavior? Sir, Z is equal to 1. This is the condition for ideal behavior. Now, suppose, for example, I have taken a gas and then see what is the way with which the variation is observed at different temperatures. Case number 1. Case number 2. Case number 3. Right. Now the examiner will ask you, I have taken variation of Z with respect to pressure for a given gas at temperature Tx, blue color, and then we are having the Ty, some other temperature, the second isotherm and third isotherm. Now he will ask you the question, arrange the temperature Tx, Ty, Tz in increasing or decreasing order. I am asking you question that which is supposed to be the highest temperature? Is it Tx or Tz, which will be highest temperature? Come on, anybody can help me? I'm redefining the situation. Consider a gas and we are studying that Z is to be plotted versus pressure. I got a different type of graphs, Tx, Ty, Tz. Question is, which one is highest temperature? Abrarul Hakhani, he is saying, sir, Tx is highest. Some of you are saying Tx is highest, some of you are saying Tz is highest. Okay, naturally, Ty will be not be the possible answer. Come on. Now, when I asked to those students who are talking about Tx is highest temperature, I think they'll say, sir, it is supposed to be the graph which is nearest to ideal behavior, right? This is the graph which is close to ideal. This is tending towards ideality. This is far away from ideal behavior. This is far away from ideal behavior. So those students who are thinking that answer is Tx is high temperature, yes, they are going on the right track. That in the previous classes, what we said, as the temperature increases and pressure decreases, gases tends towards ideality. Okay, therefore remember that we are having Tx value is supposed to be highest, right? So those who have given answer Tz, let's have a look here. In this case, Tx is supposed to be more than Ty, more than Tz. Okay, now take this part, then I'll go to next screen. Go ahead. Usman Abdul Alim, beta, we do belong to IIT section or NEET section or AIM section. Please refer that one. Usman Abdul Alim. Okay. Suhail is saying that he didn't understand because he has not given proper attention to my explanation. Right? Suhail, did I explain why it is high? Did I explain that one better? See the screen? See the screen? Below that I have written with black letters, something black colored letters. See that one? Are you able to see that one? Explanation is there on the screen, and explanation I have given, I have explained that one, and I have written also. Please have a look on that beta. Come on, is it over? Shall I proceed? Okay, you got Sohail, answer, you got it. It is there on the screen. As the temperature increases, pressure decreases, we are having ideal behavior, tending towards ideal behavior. Which graph? Blue graph, red graph, green graph, which is close to Z is equal to 1. That corresponds to high temperature. Mohammed Abrar, pressure is inversely proportional to temperature. माफी चाहता हूं बेटा, आपको gaseous state नहीं मालूम आपको क्या चीज है. I think you don't know what is gaseous state because you are saying pressure is inversely proportional to temperature. अल्लाह रहम करे, अल्लाह रहम करे. कोई बात नहीं, कोई बात नहीं. आपको उसका शौक है बेटा टाइपिंग का, आप शुरू से ऐसा करते हैं. खुदा के लिए चैट बॉक्स पे बहुत ही जरूरत है तो आइए, अदरवाइज आप ना दिमाग इस्तेमाल कीजिए, थॉट प्रोसेस में जाइए. वही बोलो ना, रॉन्गली टाइपिंग का मतलब ही वही है कि हमको टाइपिस्ट बनना नहीं है, हमको थिंकर बनना है बेटा. सब उस वास्ते क्लियर लिख दिया मैं, तो सोचो. अब बोलो सोहेल पूछे हैं तो मैं उनको समझा दिया, उनका रेस्पॉन्स अभी तक नहीं आया. क्वेश्चन पूछना अपना काम है, डाउट समझाने के बाद में समझ में आया नहीं आया हम नहीं बोलना चाहिए, क्योंकि हम लोग गैर जिम्मेदार लोग हैं, है ना बेटा. चलो, वेरी गुड. चले प्रोसीड. ओके ओके, ठीक है. बोलने के बाद अब तो अब अंडरस्टूड है, आप समझ में आ गए आपको. वेरी गुड, वेरी गुड. ये सब ब्रॉट अप का है प्रॉब्लम. यस, शैल आई प्रोसीड बेटा? इज इट ओवर? नाइस. कम ऑन नाउ, come to the discussion. This person, Andrew, has taken carbon dioxide and he know that the temperature at which carbon dioxide, as you said here in this case, it is going to closer value Tx, like that. He calculated the what is the temperature at which carbon dioxide will behave as an ideal gas, right? It is supposed to be something around 50 degrees centigrade, not exactly 5, around 5 degrees centigrade. Okay, fine. So once you are having that temperature, remember that temperature is called as boil temperature, B-O-Y-L-E, not B-O-I-L-E, Boyle's law, as you say. This temperature, which temperature? See here, the temperature at which this is coinciding, Z is equal to 1. If you are calculating the temperature here, as you are talking about that one, that temperature is called as boil temperature. Okay, so he got 50 degrees centigrade. Come on, now please concentrate on the screen. Try to enjoy all and each and every statement which I am trying to explain. This is a beautiful discussion to get 4 marks. For IIT students, it is a possible paragraph question in advanced examination. Suppose, for example, if I am taking P versus V, right, at constant temperature, what is that known as? Isotherm. Okay, I made constant temperature. What Andrews has done, he said that he found that the ideal behavior of carbon dioxide is observed at 50 degrees centigrade. Nice. Once it is so, he has taken 15 degrees centigrade, right? These values are not exact and I don't want values also. I am a conceptual teacher. You want concept here, not number game. No one is going to ask you number. Now he, at this temperature, he want to study isotherm. Is that clear? Now, once you are having is it visibility clear to all of you? Screen visibility is clear, beta? Yes. Ejaz, you check your system, beta. There is no problem with others. Ejaz is having some problem. You please check your system. What he observed is the graph is supposed to be something like this. See here carefully. The graph was something like this. Okay. Now, if the graph is like this, he was very happy. Why? Because he is thinking that he is going to get a part of rectangular hyperbola, right? This part he is selecting. Okay, I am getting something like rectangular hyperbola. Therefore, he was very happy and slowly he is increasing the pressure. As he increases the pressure, the volume goes on decreasing. At different values of pressure, he is trying to plot the graph. He got this type of graphical representation, right? He was very happy and slowly he is changing that. But suddenly what happens here, he got this type of variation. And then after that, when he is gradually changing the pressure or increasing the value, it is observed like this. The graph is going to be like this. Actually, what is our job? Our job is very simple, sir. Whenever we are trying to draw a plot of what we can say pressure versus volume, we should get the graph known as a rectangular hyperbola. Initially, he was getting rectangular hyperbola, but suddenly he got a straight line and then suddenly it is increasing. Okay, he was thinking something as a scientist, okay, let us forget about it. Then he has increased temperature to 25 degrees centigrade, some value. Now, what is our conclusion? Just know what we have done. As you increase the temperature, gases tends towards ideality. What is the proof of that? See here, the proof is like this. We got longer section of rectangular hyperbola. See here, this part is only for a small portion we are getting. For a small change of pressure, we are getting rectangular hyperbola. And then we are thinking it may behave ideally, then suddenly there is a change. But when you go to higher temperature, this length of this rectangular hyperbola part is increasing. Okay, this means to say as you increase temperature, gases tends towards ideality. Then it happens to be again something like this. And then it is increased to like this. Okay, fine. Suddenly he has increased temperature further, and here what we should say that if you are working hard, God also helps you. Exactly the similar way, when this fellow is working, luckily somehow he got an idea, because now 15 is over, sir, 25 he has taken, that must be 35. But uh, typically he has taken 31 degrees, 31.1 he has taken. Then he got a typical type of curve. What is that? Try to enjoy this. He got something like this. He got a straight, almost this type of part, and then there is a jerk here. There is jerk at this point, right? Now, once you're having jerk, then what he observed that he has further increased temperature, and he went to that temperature. Which one? 50 degrees centigrade. He got very systematically rectangular hyperbola. Okay, that is as quite obvious that as we are going towards a higher temperature, right? Let me remove this part. I should try to smooth. Nice, very good. Come on, here there is a point. This is 50. That's all. After this, he came out of the lab and he was just staring to that graph, what to do, what to do, what to do. Then slowly his mind gets open and he visualized that, suppose, for example, if I am having this type of discussion or variation, it is concluding something like this. What is that? First of all, what he understood that here in this case, we are having a part of rectangular hyperbola, but not perfect rectangular hyperbola. It means the whole section where you are having available here must be having gas. First conclusion. It means it may be having gaseous state of matter. Naturally, he has taken carbon dioxide as gas. But once you are having this one, what is the meaning of this? At constant pressure. See here, pressure is almost constant. Exactly not straight line, slightly inclined, but pressure is almost constant. Right? The pressure is constant. Once pressure is constant, he thought something very typical, which you also know. What do you know? Go to physics. In physics classes, what you people do, you take a beaker in which you are having water and keep thermometer. Keep a burner below the beaker and at room temperature, suppose for example, reading of thermometer is 25 degrees centigrade. Now on the burner. Once you on the burner, what you are doing? You are supplying heat energy. As soon as you start supplying heat energy, your eyes will go, your eyeball will see the temperature scale. Sir, I am supplying heat energy, therefore I am expecting the reading of thermometer should increase. Definitely it goes on increases. You are happy, sir, I am getting my conclusion. As your goes on continuously supplying heat energy, reading of thermometer increases 25, 35, 40, 50, 60, 70, 80, 90. Once it becomes to 100, then even though burner is on, reading of thermometer will not increase. You are checking once again whether burner is on or off. Sir, burner is on. You have removed thermometer thinking that this thermometer is not correct. Let us take a new thermometer. So you have taken same thermometer, again you are getting same behavior. Then what you have to conclude? You have to conclude, sir, according to physics lecturer, here the amount of heat energy which we are supplying is hidden inside, and therefore they say it is latent heat. Sir, where it is going? Can you destroy energy? No. Law of conservation of energy says we cannot create, we cannot destroy. Sir, where it is disappearing? It is not disappearing, it is used to have conversion of physical state from liquid to gas. That means wherever we are having constancy of any property, remember that there must be a change of phase. Gas phase is, sorry, liquid phase is converting to gas phase. That heat energy is called as latent heat. Now from that I am trying to enjoy here, since there is a constancy of pressure, it means there is a phase change here also. Yes, this means to say in this particular area, we are not having gas. What is there with us? Sir, we are having two substances available. That means here we are having neither complete gas nor complete, both of them. Both of them are available. We are having gaseous state as well as we are having liquid state, but both of them are in equilibrium. That state of gas where you are having liquid in equilibrium is known as vapor state. Yes, there is a difference between gas and vapor. For a supermarket person, and of course for us also, till today, you may be thinking gas means vapor, vapor means gas. Today we are saying no, sir, gas is different, vapor is different. Here we are having perfect gas, here we are having vapor. What is the definition of vapor? Just wait for a while, we will enjoy that one. And then he is observing what is this problem here, what is happening. For a large increase in pressure, there is a small change in volume. I'm repeating again, for a large change in pressure, there is a very small change from here to here, this much small change. What should be this one? Sir, this must be liquid state, because in case of solids, there is no effect of pressure. However, in case of liquid, there will be impact, but impact or effect will be negligible or small. Okay, he suggested that here we are having pure liquid state. Yes, sir. Here we are having pure gaseous state. In between, we are having both available in equilibrium. For a large value of volume, if you increase temperature, the gas is tending towards ideality. Therefore, this space, the length of volume is decreasing. Okay. Here we are having again liquid and gas are in equilibrium. Okay. Once you are coming to this point, then there is a small problem to you, sir. What is here going on? Nothing is going on. Instead of writing 15, 25, then 31 directly, come on. After 25, 26. What your mind says? Your mind says nothing, sir. Length of this constant pressure value decreases. Volume change will be less, right? 27, further less. 28, further less. 29, 30, and 31. That length has become simply a point. And this point is known as inflection point. There is a change. Jerk. Thoda sa jerk aa raha hai. It is not appearing as a straight line. This is the point where you are having change. This is minimizing as you are increasing temperature. Now what he has done? He has taken an area. With that jerk point, he has selected the area. Within this whole area, we have vapors. Very good. Right hand side, we are having gas. Left hand side, we are having gas. Above this also, we are having gas. So Andrew has got a new information that yes, we are having vapor state available. What is vapor? Wait a minute. Wait a minute. Come on. Now you may have a question, sir. Here you are saying gas. I am very happy. Here you are saying pure liquid. Very comfortable. And both of them are equilibrium. Also, again, I am happy, sir. And here in this case, also gas because we reach ideal behavior. Now the question comes to your mind as a student or as a scientist or doctor. Who is this fellow, sir? What is available here? Remember, this is a state of matter which is having density in between pure density of carbon dioxide gas and pure density of liquid carbon dioxide. I'm repeating the sentence once again. The state of matter available here in this case has density in between the density of gaseous carbon dioxide and density of liquid carbon dioxide. That means it is neither perfect gas nor perfect liquid, nor it is an equilibrium mixture. It is something different. This different physical state of matter is called critical state of matter. Yes, today we are trying to understand critical state of matter with the help of Andrew's graph, and therefore this temperature is known as critical temperature, TC, not your transfer certificate. C is subscript here, and this corresponding pressure is known as critical pressure, and corresponding volume at TC and PC, these are called as critical volume known as VC. Got the point? Yes. Therefore, ढूंढने कुछ और गए थे, मिल गया कुछ और, right? आग ढूंढने गए थे, पैम्बरी मिल गई. Exactly in a similar way, he was thinking to apply Boyle's law in a different style, but he got very good approach known as critical state of matter. Point number one, sir, what is critical state of matter? Very simple. Critical state of matter is that state of matter where property of matter is in between the property of gas and liquid. For example, density, right? Point number one. Point number two, that is whenever we are discussing critical states, sir, can I visualize critical state? No, right? How to for that? I can show it very systematically in case of notebook. In case of marker also, I cannot show you on the board. Here is on the screen, definitely not possible. But in case of notebook, it is very good when I take a pencil in the classroom from a student. I'll explain you how does it look like. यहाँ कोशिश करता हूं मैं, नहीं आएगा यहाँ पे. Suppose for example you are having a liquid in a test tube. When I am having a liquid, what happens, sir? Liquid appears to be like this. समझ में आया? What do you say? Physics people say this is called meniscus. Sir, in general, all liquid forms lower meniscus except mercury. Mercury forms upper meniscus. Right? So here we are having liquid state, here we are having gaseous state, and there is a meniscus here. Remember, critical state is that state of matter where meniscus disappears. आपको मालूम नहीं होगा कहाँ यहाँ लिक्विड है, लिक्विड है, लिक्विड है, सर सर खत्म हो रहा है, अब क्या हो रहा है नहीं मालूम सर, गैस है. You are unable to look out that line, boundary you cannot define, boundary you cannot define. Therefore people say critical state of matter is that state of matter which do not have boundary. Okay, if you are not having boundary, there is no surface available. If there is no surface, yes, go back to physics class. What happens, sir? Surface tension becomes zero. Surface tension becomes zero. Okay? These are different ways to enjoy the definition of critical state of matter. Very good. Come back again to critical state. Sir, in our examination, how to enjoy critical state? Remember, critical state is that state of matter where slope of the graph. Can you please tell me what is slope of this left-hand side? Negative. What is this? Negative. Here, negative. Here, negative. It is straight line, 0. Here we are having straight line, 0. Remember, at critical temperature, at TC, at this particular point, what happens? Two things are very important. What are those two things? Number one, dou P by dou V. Instead of writing dP by dV, I am writing dou P by dou V. This is mathematical method whenever you write something here constant, Pc. How to read it? Doctors, don't take tension because of the expression. It is very simple. What you have to learn here? Variation of pressure. No, sir. Small variation of pressure with respect to small variation of volume at critical temperature. That is nothing but slope of the graph. MPC people say, sir, this is slope of the graph because dy by dx, right? Therefore, what is the mathematical definition of critical temperature? At critical temperature, slope of the graph becomes 0. This is one thing you have to learn. Second thing is, by PC students, please try to enjoy this in a positive way. Second differentiation, you know it. You have done mathematical tools. For example, first differentiation of displacement is equal to velocity. Second differentiation of displacement is equal to dash acceleration. Yes, sir. Exactly in a similar way, if I say dou square P by dou V square. Yes, sir. At which condition? At critical temperature. This is also 0, right? This is mathematics people say this is the condition for inflection point. This is the condition for critical state of matter. But luckily, at critical state, we have inflection point. Therefore, these two are definitions. Advanced examination, A bit, B bit. Both are correct here in this case. This is the slope is equal to 0 is a characteristic feature of critical state of matter at critical temperature. At the same time, since it is having inflection, therefore this is the criteria to be satisfied wherever you have inflection in the graph. Second differentiation of y property with respect to x property at a constant parameter known as critical temperature in this case is equal to 0. Is it clear? Right. Now, with respect to this, what you have to learn, sir, what is the value of TC, PC, and VC? Naturally, those values will be different for different gases. The temperature, critical state temperature, pressure, volume depends upon nature of gas, right? Do you have general formula? Yes, we have general formula. Derivation is also available, not for us. Only we have to remember what is mathematical expression. Okay, do one thing. First of all, take a fresh page, heading write down Andrews isotherm of carbon dioxide. Below that, write down one more heading. That heading is called critical state of matter. ठीक है? Figure जरा systematic ड्रा करो. In that point, I'll write all the things which I have dictated or explained to you in a systematic manner. Go ahead. Draw that. Take pencil and pen and draw systematically the graph. Okay. Go ahead. Go ahead. TC is known as critical temperature. Please write down full forms. I am lazy person, therefore I am not writing. You people should be very much crazy. You please write down full form. Is it that figure is over? Figure is over? No, just wait. Don't write. Just wait for a while. All these points I have explained to you. No, there is a definition. Just wait. No problem. Don't do anything. Just wait. I said wait. Don't write. Listen to me. Finished. I have said number of things here, and now let us take definition of TC. What is critical temperature? Critical temperature is defined as the temperature below which you can convert a gas to liquid. What is the problem here? Sir, below critical temperature, I am having gaseous state, no, liquid state also along with each other equilibrium. Sir, which we call vapors. Now, when you are having vapors, there are horses in vapors can be converted to liquid by application of pressure alone, right? That is called condensation. Vapors are condensed to liquid by application of pressure alone, right? इसको बोलेंगे condensation. लेकिन ये अगर ऊपर चले गए आप, if you go beyond TC, it is not vapor, it is a gas. You cannot convert gas by application of only pressure, right? Gases are liquefied by increasing pressure as well as decreasing temperature. There is a difference between gas and vapor. So what is critical temperature? Critical temperature is defined as the temperature below which a gas can be liquefied by application of pressure alone. Above TC, a gas cannot be liquefied by application of pressure. First, you should come below TC. TC is the temperature below which only pressure is required for liquefaction. Whereas, if your gas is having temperature more than critical temperature, you cannot liquefy whatever with tons of pressure you apply. First, what you should do? Come below TC, come to this lower value, then you can make liquefaction. Right? Next. The values we have to remember, all these values you have to remember, especially doctors. Yes, all these are important for you. For IIT people also, we have a chance of numericals here. Now, when I am taking this one, VC is 3B. Who is this fellow? B and A, Van der Waals constant. PC A by 27, B square. TC 8A by 27 are B. Now, VC, let us play a game, right? For that purpose, we should talk about for that purpose, what we say, sir, we are having 3B. If I am taking B value, what is B? 4 times molar volume. 4 times molar volume. Then we say 12. Therefore, remember, ratio of critical volume to molar volume is known as 12. Integer question is possible. What is VC? Critical volume. What is VM? Molar volume. PC is equal to A by 27 B square. B square. Okay. Then it is dependent upon A and B value. But very important thing is TC. TC is equal to 8A by 27 RB. Now listen carefully. Insta for there on the chat box, Muhammad, I don't know this fellow. Anas, okay. दिमाग यहाँ लगाइए अनस बेटा, यहाँ रखिए दिमाग. जो बोल रहा हूँ उस पर ध्यान दीजिए. बाद में देखेंगे, सब पूरी दुनिया बाकी है. TC is 8A by 27 RB. Remember, TC is directly proportional to A. If you increase the value of A, TC increases. If TC is more, a gas can be easily liquefied. चलिए पीछे से आइए. Last class में क्या बोले थे? As TC increases, if you want to go reverse from the previous class, as IMFA increases, what you said? Intermolecular force of attraction increases. What happens? Sir, A increases. If A increases, TC increases. If TC increases, easier liquefaction. Which gas? That fellow will give you, right? Gas 1, gas 2, gas 3, gas 4. Name will be given to you. TC values are given to you, and that fellow will ask you, which can be easily liquefied. That gas can be very easily liquefied, which has highest possible critical temperature, easier liquefaction. Okay. So for liquefaction, you should have higher value of TC. Okay. And intermolecular force of attraction, how it depends? Sir, we know it as molecular mass increases. Yes, intermolecular force of attraction increases. So ultimately, liquefaction को आप molecular mass से भी जोड़ सकते हैं. ऐसे questions आएंगे. चलिए, last discussion is, okay sir, when you are saying Z, we said Z is equal to PV by RT. Now that fellow can ask you, what is ZC? What is ZC? It is compressibility factor at critical condition. It is nothing but PV by RT. No, sir. PC VC by RTC. That's all, right? You have the values here. Substitute and tell me what is the answer for this one, right? That is known as critical phenomena of gaseous state. चलिए, at TC, meniscus disappears. Surface tension becomes zero. Shukur Irfan, 3 by 8. Very good, beta. It's correct. You are right. Just wait a minute. Last sentence. Listen, wait a minute. ZC is equal to 3 by 8. And remember that when you are saying 3 by 8, you do not have A value here. You don't have B value. It is a constant. इसका मतलब क्या हुआ? ZC should be same for all gases. Are you able to understand? ZC is a number. Number does not depend upon nature. Therefore, conclusion of this discussion is ZC is independent and Z is same for all gases. ये आप कह रहे हैं theoretically in the class. Go to the lab. In the lab, it is observed that ZC is different for different gases. ये क्या मुसीबत है, sir? Right? Yes. It means to say Van der Waals equation is not completely correct. Yes. अब आगे ये stage पे आके, when you have this much maturity, now you are able to say, अच्छा कुछ problem है. Van der Waals equation is not applicable at all ranges. At critical range, it is not applicable. Yes. Therefore, people say that whatever Van der Waals equation is given to you, it is most easiest way of enjoying and understanding gaseous state, but not applicable always. यहाँ तक बोल के हमको खामोश रहना है. इसके बाद में हम नहीं बोल सकते because it is not in our syllabus. हाँ, इसके बाद की स्टोरी चलेगी अब BSc second year में, third year में. What to do? We should not go for that side. Go ahead. That is the end of gaseous state of matter. And you are having open field. Go ahead everywhere to enjoy problems and theoretical questions. So for any book, especially, first we have to go to notes, revise all the notes properly, systematically, then go to Avasthi level 1, both of you, because in Avasthi main book also level 1 is same as that of level 1 in case of IIT. Only from level 2 he has changed that one. Go ahead. Any question to ask? If you read today in any textbook this topic other than NCERT, then you will definitely enjoy the concept of the topic. Otherwise, if you leave it today and you want to do, ठीक है, Sunday exam होता है, हफ्ते को पढ़ेंगे, then I don't think that it is possible. You cannot enjoy the beauty of subject. एग्जाम के लिए पढ़ने वाले अलग चीज है, they are not rankers. डेली पढ़ने वाले एक अलग चीज है, they are going to be rankers. Maybe possibility. क्योंकि अक्सर आप लोगों में से पूछते हैं, हफ्ते के दिन पूछते हैं, जुमे के दिन, सर सिलेबस क्या है? मतलब लकीर के फकीर हैं, डेली पढ़ते नहीं, जुमे के दिन नींद होशियार हो गया, हाँ चलो अब भाई एग्जाम लिखना है. दैट इज नॉट द वे. दैट इज द वे, ब्यूटीफुल वे. वो बहुत अच्छा तरीका है आईपीई के लिए, इंटरमीडिएट के लिए अगर आप हैं तो बहुत अच्छा तरीका है. Monday, Tuesday, Wednesday, Thursday, enjoy. Friday, Saturday, no problem. But if you want to become a ranker, 24/7 into 365. Any question to ask? All of you, please listen carefully. Tomorrow I am not available at Hyderabad, right? I am busy somewhere else in the Hyderabad only. So tomorrow we don't have physical chemistry class. Day after tomorrow, we'll enjoy some problems based on this. Next week we'll start next chapter. Tomorrow we do not have physical chemistry class. Not all, only physical chemistry. Is it over? There are so many 4 marks questions on the screen. Please try to write down properly. Very good. That will stop here. Remaining we'll discuss in the Friday class. Tomorrow we don't have class. Thank you. Assalamu alaikum.